So we're going to look at some tree diagrams. We're going to start with the question on the right. Experiment 1 is performed. Outcome A occurs with a probability of 0.6, and outcome B occurs with a probability of 0.4. Then experiment 2 is performed. Its outcome C occurs with a probability of 0.9, and outcome D occurs with a probability of 0.1. That sounds really confusing. But they made a nice tree diagram down here for us, and the key is just to remember we're going to multiply. So first we're going to find the probability of A and then D. So let's trace it. So this is A, and then in orange we'll do the D. So the probability of both of those things happen is 0.6 times 0.1, and that's going to be 0.06, or a 6% chance. The probability of B and then C would be, well, probability B will be here in green, and then for C, we'll go down here, and that'll be the 0.9. So this would be 0.4 times 0.9, and that is going to be 0.36. So for the one on the top left, the tree diagram relates snowfall and school closings. Find the following probability, and we're going to let H, L, O, and C represent heavy snowfall, light snowfall, schools open, and schools closed respectively. And it would help to have the question. So the question is, what is the probability that the school is closed? So we need to find out how do we get to the C, and there's two ways to get to the C. For the top half, we could have heavy snow, and then we could have a closure. And this part would be 0.3 times 0.4, and that's going to be 0.12. And the other path to get to the closed is light snow. So that would be 0.7 times 0.2. And that would be 0.14. So we add up the probabilities that we have. 0.12 plus 0.14 is 0.26. So there is a 0.26 chance that the school is closed, or 26%. The last one, a stereo repair shop used a two-step diagnostic procedure to repair amplifiers. Step 1 locates the problem in the amplifier with a probability of 0.7, and then step 2, which is only executed if step 1 fails, locates the problem with a 0.9 ability. So what is the probability that the problem is found? So there's two ways to get to the problem is found. We got this way up here. There's two ways to get there. Problem found and problem found. Well, the direct method is pretty easy. Problem found there is a 0.7 chance. And the other way would be tracking this green path that I'm drawing on there. That would be 0.3 times 0.9, and that would be 0.27. So if we add up 0.7 plus 0.27, that would give us 0.97, or there's a 97% chance that we do find the problem. And for this one, what we could have done is just found the probability that the problem is not found, and that would be the pink path, and that would be 0.3 times 0.1. And 0.3 times 0.1 is 0.03. So if there is a 0.03 chance the problem is not found, that means there's a 0.97 chance of the problem being found. It's the complement. So if you have any questions, ask your math teacher.